This video has been sponsored by Nuage Networks. For more information on the Nuage Virtualized Services platform and how Nuage is delivering consistent, policy-driven automation across data centers, the WAN, and branch locations everywhere, please visit nuagenetworks.net and follow us on Twitter at Nuage Networks. We hope you enjoy the session.
After watching this video, visit ipspace.net/sdn to learn more about software-defined networking and overlay virtual networks. Overlay virtual networks are a great idea, but somehow all the clients are still on the physical network, which means that somehow we have to link the virtual world with the physical world. There might be three ways of doing that. Sometimes you may need layer 2 gateways. Usually this would be for integration with legacy equipment, like you're using physical firewalls or load balancers and they only support VLAN trunks, or you're doing physical to virtual migration, or you are offering some transition services. For example, you were a colo facility. You have old customers that have their physical servers in their own cages, and now you're offering them VM-based service, and you have to provide connectivity between their physical cage and their overlay virtual network. And sometimes they want to retain the IP addressing, in which case, well, you have to provide a VLAN, which means that you need a layer 2 gateway. Sometimes you have multiple segments that are then routed to an outside world, so you need layer 3 gateways. And quite often you have to implement some sort of network services with firewalls, load balancers, or what have you. There are numerous implementation options when considering the gateways. You can use a VM-based gateway. You can use a gateway that's implemented along other hypervisor activities in the hypervisor kernel module. You might have a dedicated x86 server that's running some code on the bare metal and doing gatewaying functionality. Or finally, you may have a hardware VTEP where overlay virtual network encapsulation decapsulation is done in ASICs at terabit speeds. Which one would you choose? It all starts with the performance question. How much bandwidth do you want to pass through that gateway? Second, you have to consider the integration with the control plane. How will you integrate your SDN controller with this gateway? Next, how will you integrate the cloud management system with this gateway? So if you configure a new tenant in the cloud management system, if you assign an outside VLAN to that tenant, will you be able to automatically deploy that definition into the gateway, or will you have to write your own glue? And finally, how will you integrate with the existing WAN infrastructure like MPLS VPN, which is particularly important for MPLS VPN providers that want to enter into the cloud services business. Let's start with the easy one, VM-based gateways. This is a no-brainer. You take a VM. It can be any Linux-based VM, for example. People usually use Linux for this. You implement whatever you wish in that VM. You can use a Linux bridge if you wish. You can use Linux-based forwarding. You can use IP tables. You can use a Squid or Nginx for reverse proxy or load balancing. So you use anything you wish in that Linux instance. You can also put an A10 or F5 or Citrix or whatever load balancer there or firewall from your preferred vendor. And then you just connect that VM to multiple subnets, or let's call them segments. One subnet here might be VXLAN based or whatever, GRE based if your solution uses that. The other subnet might be VLAN based. Problem solved. Do keep in mind that if you send the traffic through a VM, you usually won't get stellar performance. In most cases, if the vendor didn't do a good job, you would get 1, 2, maybe 3 gigabits per VM. If the vendor did a good job, you will get up to 10 gigabits per VM. So, do you need a hardware gateway or not? It depends on what the performance requirements are and what the integration requirements are. In some cases, particularly if you don't have an SDN controller, integrating a gateway with the overlay virtual networking solution might become a do-it-yourself exercise, or sometimes even mission impossible, in which case you might be better off with VM-based appliances. For software gateway performance is usually in, as I said, in a few gigabit range, approximately 10 gig for kernel-based and bare metal gateways, and hardware gateways usually do this at line rate, which means terabit or more. A really good question, when you quote performance in terms of gigabits per second, is this for iMix or maximum packet sizes? You see, that's why I'm saying between 1 and 3 gig. iMix is approximately 500 byte packets, and on a typical Linux-based appliance using default Linux TCP stack, you would get a bit more over 1 gig. Maximum packet sizes, obviously, you would get 2 to 3 gigs. It also depends on what you're doing. If you're doing packet forwarding, then you are limited by the packet size. If you can do TCP offload, then you can push way more through the VM because the hardware NIC is doing some of the hard work. As always, it depends. Before buying any solution, do some performance testing based on the workload that you expect in your production deployment. Would you configure and manage gateway out of the SDN controller? This is a fantastic question and a great lead in to the next slide. Thank you. The hardware gateway obviously needs the mapping between the overlay segment and the VLANs number. It needs mappings between the MAC addresses of the VMs and IP addresses of the hypervisors, and it needs some flooding information. It could be an IP multicast address if you use IP multicast-based VXLAN, or it could be a list of hypervisors if you're using source node-based packet replication that most non-multicast-based platforms can use. The solutions obviously range from do-it-yourself to more or less full-blown integration. There are two solutions that you can use for more or less full-blown integration. One is OVSDB, which came from the Nicira's product, which is now VMware NSX. It's also used by others, including Nuage VSP. Or you can use EVPN or Layer 3 VPN, depending on whether you do Layer 2 or Layer 3 connectivity, which is, for example, supported by Nuage VSP and Juniper Contrail. Now, how would you integrate your gateway with the SDN controller with OVSDB? Let's go into what OVSDB is first. It's actually just a database query and update protocol. There are OVSDB schema that define the tables that you need to describe, for example, a physical switch. And there's another table that describes the MAC reachability information. And there's another table that describes IP subnets per tenant. And there's another table that describes VLAN to VXLAN segment ID mappings, and so on and so on and so on. OVSDB is just a protocol that allows the controller to manipulate those tables on the physical gateway. In the hardware VTEP schema, which is what the gateway needs to support to be able to talk with the controller that would then configure the gateway, that schema contains the description of the physical switch, the description of the ports on the switch, the description of a logical switch, and logical switch is a subnet. So you have one logical switch per subnet. You have one router per tenant usually, which brings together multiple logical switches. You have mappings between a logical switch and a VLAN on a physical port. And then you have the mapping of local and remote MAC addresses to either the IP address of the gateway in case of local mappings, or to the IP addresses of the hypervisors in case of remote MAC mappings. The SDN controller can use OVSDB to configure the VXLAN to VLAN mappings, push the MAC mappings to the hardware gateway, and receive information about external addresses from the hardware gateway. Which means that with OVSDB, you can create subnets that are bridged to the outside world, or you can create logical switches that are routed to other logical switches and to the outside world. So you can establish layer 2 or layer 3 connectivity with OVSDB. Obviously, if you want to integrate this with MPLS VPN, you have to integrate it through external VLANs. So it's like inter-AES option A. A question I got from Luis, isn't BGP superior to OVSDB since it allows layer 2 and layer 3 semantics? No, both allow you to configure layer 2 connectivity from the overlay virtual network to the physical world, or layer 3 connectivity, where with layer 3 connectivity you would have to have the router on the physical gateway. On the other hand, with BGP, you can only exchange reachability information for already configured segments. Whereas with OVSDB, because you can manipulate all these tables, you can also provision new segments. Where do the OVSDB tables reside? The OVSDB tables reside in either the hardware gateway for standalone gateways, or you might have a separate hardware switch controller, and then this hardware switch controller would control multiple gateways. Are they stateful? Well, depends on how you define stateful in this case. The controller, the SDN controller, wouldn't expect them to survive the gateway reload. So when the gateway reconnects, it would check whether new information needs to be pushed to the gateway. But we also need to be able to configure VRFs and routing on the hardware gateway. With OVSDB, what you can do, you can say, well, I have this routing instance, and it has these internal subnets and this external subnet. Obviously, if you want to run a routing protocol between this external subnet and the outside world, you cannot configure that with OVSDB because OVSDB doesn't have a schema to do that. In that case, the solution on the next slide might be a better option.
Ivan, if I may say something here. In general, like OVSDB, as you said in the beginning, is a protocol, and a lot of these things are additional tables in the schema, right? Configuring VRFs and stuff like that. And the schema is evolving, and I think there are already additions there for layer 3, and people are working on additional extensions on the basic OVSDB schema for all the other functions.
Perfect. Thank you. So today, what I described is based on the currently published schema, which contains layer 2 and layer 3 connectivity. And as Dimitri said, people are working on extensions that will allow you to, for example, configure routing protocols. On the other hand, if you want to integrate your SDN controller with the gateway using EVPN or layer 3 VPN, obviously you can do that, and we discussed already how a lot of these things would be done. However, you have to configure the gateway somehow. You can do that using NETCONF, or I think Nuage can also use XMPP in that case to configure the gateway. But do keep in mind that there is no standard NETCONF, there is no standard data model, which means that in this case, the question of which gateway can I use with which controller and which cloud management platform becomes a slightly more interesting exercise. Also, even though EVPN is a standard, it contains at least 3 different address subfamilies. One is the MAC-to-VTEP mapping. so the mapping between MAC addresses and hypervisor or gateway IP addresses. Then it can contain the IP addresses, so you can use that for either IP routing or proxy ARP. And it contains a VTEP flood list that you need for flooding of multicasts and broadcasts. Some products, even though they speak EVPN, don't use all three of these address families. And some gateways may not support all of them. So you have to be careful yet again when considering EVPN, whether both ends of the solution support the same set of information. To walk you through an example, let's assume that we have a PE router that is running some MPLS VPN across some WAN network. So we are exchanging VPN v4 routes here. And now we are adding VSC and Nuage VRS to the picture. First, we would establish an MP BGP session between the PE router and VSC. And then the PE router, based on how you configure things, would send VPN v4 or EVPN update to the Nuage VSC and vice versa. So they exchange reachability information. And then VSC would use OpenFlow to install the forwarding entries with the proper BGP next hop and label in VRS. As the VM sends a packet to the server over here, because the server is in a different subnet, it sends the packet to the MAC address of the gateway, which resides in the VRS. So the packet would land in the layer 3 code and the gateway would do layer 3 lookup. Obviously, this happens if we are talking about layer 3 functionality, for example, with MPLS VPN. If we're talking about EVPN, the subnet might stretch further out toward the WAN, in which case the VM would send the packet to some other MAC address, and the layer 2 code in VRS would do layer 2 lookup based on the EVPN information. In any case, the IP packet is eventually encapsulated in something, which can be MPLS over GRE over IP, or it could be VXLAN in UDP over IP, and it's sent to the PE router. The PE router then receives the either MPLS VPN packet or VXLAN packet, does whatever it does. So for MPLS VPN packet, it would just swap the label. For VXLAN packet, it might do more and sends the packet toward the WAN, and vice versa. So if we talk about hardware gateways, first you need to figure out what bandwidth you need. Low bandwidth, go with VMs, or maybe dedicated x86 servers. High bandwidth, go for a full-blown hardware VTEP. Next question is the integration requirements. If you want to connect the overlay virtual networks to VLANs, you may go with the gateway, maybe on bare metal x86 server, that comes with your platform. Or if you want to have a hardware gateway, you have to look for one that supports OVSDB or EVPN, depending on what your SDN controller can support. Finally, if you want to integrate straight with the MPLS VPN WAN, for example, you're an MPLS VPN service provider and now you want to offer cloud services, then you should look for an SDN controller and the hardware gateway that can support either EVPN or layer 3 VPN, depending on what services you want to offer. In any case, based on your decision on the services you want to offer to your customers, you should choose SDN controller that will eventually support all the options that you need. If you like this video, go to ipspace.net/cloud to explore other overlay virtual networking webinars.